Projectile motion formulae. To work out the projectile formula for range. Now range is the horizontal displacement. So looking at horizontal motion and selecting this as the positive direction, S equals Vt. This is a standard formula used for horizontal motion. S is the horizontal displacement, which is r. V is the horizontal velocity component, which is u cos alpha, and it doesn't change anywhere in the motion. Horizontal velocity remains constant. And t is the time of flight. We already have a formula for the time of flight, so we need to substitute these three into here, and that gives us this formula. We need to rearrange. We want the sine alpha and this cos alpha term together, like so, because this is a double angle identity for sine. We can replace this with sine 2 alpha, like so. So here is our formula for horizontal range. And this is the final one for the projectile formulae. We want the equation of the trajectory, so the equation of this n-shaped curve. And we want the equation as y as a function of x. So we'll start by looking at the horizontal direction, and I've taken this as my positive direction. This is a standard formula for horizontal motion. The S is horizontal displacement, which is x in this graph. V is u cos alpha. We substitute those two in, and we get this. Rearrange to make t the subject. Moving on to vertical motion. So vertically, the displacement is y. So taking the upwards direction as positive, vertical displacement is y. The vertical velocity component was u sine alpha here. We're not interested in the vertical velocity component. I've crossed that out. And we have a formula for t already, which we worked out here. And we're going to use that at this point. So a Suvat formula not involving v, S equals ut plus half at squared. And we substitute these in. So S is y, u sine alpha, t from here, plus half, a is minus g, t squared from here. So we have y as a function of x. We need to simplify all this. This u and this u will cancel. This one's in the denominator. Sine over cos will give tan. So this is the first term. Then that minus. Everything in the brackets here is squared, so we have x squared over u squared cos squared alpha. So that gives us this term. Now we know that 1 over cos squared, which is what we have here, is secant squared, and secant squared using an identity can be written as 1 plus tan squared. So now we have this. And just to go over that once more, the 1 over cos squared here is replaced with secant squared, and secant squared gets replaced with 1 plus tan squared here. So we have a quadratic equation. We've got an x squared term, and we have an x term, the quadratic term and the linear term. I've just rearranged their order. I've put all of this first here. And now we can clearly see the x squared term and the x term. This equation has the same form as this equation. So y equals minus a, which is this part, the minus a here, x squared plus b, where this is b, times x. the coefficient of x squared for this quadratic equation is negative, and that means we get a n-shaped quadratic curve, which is exactly what we see here.